In the late 1800s, American expansion was a matter of scale. Railroads, bridges, and early skyscrapers required one specific material: steel. The engine driving that growth was the Bessemer process. It worked by blowing air directly through molten iron, burning off carbon and purifying the liquid into steel. But the Bessemer process had a timing conflict that made it difficult to scale. It was a friction point that cost the industry millions of dollars in wasted heat. While the demand for steel was effectively infinite, the primary method for making it was restricted by a physical bottleneck. The problem was a mismatch of speed. Blast furnaces operate continuously, producing a 24/7 stream of molten iron. Furnaces flow continuously, but Bessemer converters are batch processors, taking metal only at exact times. Forced to wait in transit, the iron's temperature drops, ruining its chemical consistency. This cold iron clogs machinery, destroys steel batches, and forces the entire mill to a complete halt. Aligning these two different production speeds was a massive logistical hurdle. It required a manager who understood the physics of the floor. The search for a solution leads to the Edgar Thomson Steel Works in Pittsburgh, the most important site in the American steel industry. This mill was run by William R. Captain Bill Jones. He was a Welsh immigrant who had worked in iron mills since childhood and served as a Union Army captain. Andrew Carnegie handled the boardrooms and the financing, but Jones was a superintendent who spent his time on the mill floor. He was a practitioner of metallurgy. Jones's military background and technical precision gave him a unique perspective on the mill's operations. He realized that the factory's chaotic flow could be stabilized with a single massive structural addition. Jones designed a solution to the bottleneck: an enormous insulated reservoir placed directly between the continuous furnaces and the batch converters. This was the hot metal mixer. This cross-section shows how it functioned. By pooling the iron into this massive insulated vessel, the metal retains its extreme heat for hours instead of cooling down in the open air. As different batches of iron from various furnaces enter the mixer, they mix together. This swirls the different temperatures into one uniform, predictable level. The result is a consistent chemical composition. Now, when the Bessemer converter is ready for a batch, the iron is at the perfect temperature and ready to go. The hot metal mixer removed the primary bottleneck in the Bessemer process. By bridging the gap between continuous input and batch output, Jones enabled the mill to operate with a speed and consistency that had previously been impossible. Carnegie's mills became the most efficient in the world, and the hot metal mixer was soon adopted by steel plants across America and Europe. But the industrial world of the late 1800s was inherently dangerous, even for those who understood it best. In 1889, while inspecting the production floors at the Edgar Thomson Works, Captain Bill Jones was struck by a catastrophic explosion of molten metal. He died from his injuries at just 50 years old. The news shocked the industry. The man who had tamed the flow of molten iron was ultimately killed by it. We often remember the names of the men who owned the companies, like Carnegie, but the physical reality of the industrial age was built by technical problem solvers like Jones. The steel that forms the modern skyline exists because engineers found ways to make production faster and more reliable. Jones did more than design a container. His mixer solved the fundamental timing problem of the steel mill, allowing molten iron to flow reliably into the rails and beams that built the landscape of the nation.
Thank you for watching. Please like and subscribe. It really helps us.